Deploying an Lxc container that can provide the capability of Python on a Cisco device is a very simple process if we take it from the perspective of what it is we're trying to accomplish by breaking it up into smaller, more manageable pieces. Now, my plan is to, on CSR2 in this lab, to configure a runtime environment that is going to support containers, deploy a container, which will end up being a CentOS Linux operating system, and then provide connectivity such that that resource can communicate to the outside world. In order to be able to do that, there are a few things I want to verify in my lab. So first of all, I am sitting on CSR2 where we're going to implement this, and I want to validate that I can actually get to the outside world from this device. I'm pinging 8.8.8.8 from CSR2, and I'm traveling through CSR1 to the internet. And if I do a show IP OSPF neighbors, we'll see that I have a neighbor adjacency with the CSR1 device in this lab. Now, the first thing that we need to keep in mind is that when we're going to be implementing something like an Lxc container in a Cisco iOS device, we need to be able to step back and take a look at it from a 30,000-foot look, because if we start taking it apart and looking at it from a theoretical perspective, it's going to make the configuration easier because we're going to see a phased and ordered approach to doing our deployment. So what I'm going to do is I'm actually going to come over here and I am going to draw in a box, and that box is actually going to be representative of my CSR. So this box that I'm working with right now is representation of that CSR component. And we know that this device is running an operating system that is Iox Xe. This is a CSR running inside of my Eve emulation environment. Now, when we look at what's going on, bear in mind that we are going to have components that are going to be part of my Iox Xe operating system that are going to be providing connectivity. As an example, we have a physical interface that is referred to as gigabit 1, 2 in this lab, which is this interface right here. And that interface actually has an IP address assigned to it, which is going to be 10.1.12.2/24. And it's also important to understand that in the context of deploying a physical resource like a ISR or an ASR or something along those lines, the same rules are going to apply when it comes to creating resources. And we have a mixture of physical resources and virtual resources like loopback addresses. Now, when we look at this, the other thing that we're trying to understand is going to be, how can we create a container? Well, in order to be able to create a container, what we're going to end up needing to do is we're going to end up trying to create an environment that, first of all, can support a container. And in order to be able to do this, what we're going to do is we're going to need to mount something known as the Iox Service. Now, the Iox Service is just an application environment that is going to support the creation of resources that are going to take the form of what we call Lxc containers, Linux containers. Not to be confused with Docker containers. Docker containers basically made Lxc containers easier to use. However, they are still kissing cousins. As a result of what I want to be able to do, I need to be able to implement and build this environment. Because unless I have the capability of being able to host resources inside of this CSR, I can't create an Lxc container. That's a very simple process to execute from the perspective of the device itself. So what I'm going to do is I'm going to first come over and I'm going to say, I want to show Iox-service, and I want to see if that service is running. And right now we can see here that it is running on this box. Now, if I wanted to shut that service off, I could come in and say config no Iox. And what we'll see here is that the operating system is going to stop offering the service of Iox, which again is going to be an application runtime service. Now, this is not on by default. So Always make certain that you validate that the Iox service is running, and if it's not, you need to be able to turn it on. Sometimes you may need to kind of reset it. In order to be able to do that, you would just do the no Iox and then wait a couple of seconds and then turn it back on, and that should restore or populate any modifications or changes that you've made to the service. Now, the next part of this, again, like I said, is I'm going to go ahead and turn it back on. And this takes a little bit of time, so I'm going to say Iox, and we'll wait for it to start the spin up of this environment. And once the environment has been spun up, what we're going to do is we're going to talk about it a little bit more. So again, right now it's telling me that the Iox service is ready. So now if I come up and say show Iox service, we can see right now it is running. And what I want to do next is I want to talk about what we're going to need to do. So from a deployment perspective, the very first thing that we are going to take care of is enabling the Iox service or making certain that the Iox service is currently running. Now, the next phase of this operation is going to be inside of this environment. I want to create the actual Lxc container. Now, we have an Lxc container that is native to our Cisco IOxC devices called guestshell. Now, guestshell is basically just a CentOS Linux container. And as such, it is going to be able to execute applications and tools just like any other Linux operating system. In other words, we will use it for the purposes of our class to be able to look at things like Python. But that begs the question, how? Because the thing that we have to keep in mind is what we're doing is we're building an isolated environment. Technically, if we were to look at this from a 30,000-foot view, the Iox operating system is separate from the Iox Service runtime environment. Now, when we look at that, that means that whatever we create in the Iox environment is going to need to have the capacity to communicate to resources that exist outside of that environment, and vice versa. Resources, interfaces, devices that are going to be connected to the network that are going to be governed by IOSXE is going to need to have connectivity to those resources in such a way that we can actually share functionality. Now, obviously, we are going to need to try to find a way to implement this configuration, because when we start looking at things like this CentOS guest shell that we're going to be building, it is going to need to have interfaces. Those interfaces are going to be the way that this device is going to be connected to the outside world. But again, that's going to be what we refer to as a guest interface. That guest interface resides inside of the Iox service that we have been discussing. And it's going to need a number of things. First of all, the interface is going to have an IP address. We're going to have to supply a gateway of last resort in order to be able to allow the CentOS machine to communicate to the outside world. And we're also going to, more often than not, need to leverage the capabilities of some of our network services like domain name services. But the problem that we're looking at here is this resource, this device that we're creating, that we're going to spin up in this Iox environment, is isolated. So what we need to do is we need to come up with a way of being able to afford it connectivity to the outside world and vice versa. In order to be able to do that, what we're going to do is we're going to leverage the power of logical interfaces. In fact, we're going to have a special kind of logical interface that we're going to be working with, and that logical interface is going to give me the capability of being able to poke a hole into this veil or this isolation that we're implementing, whereby now what I can do is I can create a logical interface that's going to allow me to be able to bridge that gap. And we're going to call this interface a virtual port group. It is a virtual port group interface, and it will actually be bound in its creation to this guest interface that we're creating. And because it has a point of presence in both worlds, that means now I can actually use this interface to be able to provide the necessary communication to get this bidirectional exchange of information between the Lxc container and the outside world. Now, what I want to do is I want to take the steps to implement this. So first, what we're going to do is we're going to create this virtual interface. I'm going to need to give it an IP address. This virtual interface is going to be my way of getting communication out of the Iox service and into the Iox service. It's going to take the form of an interface virtual port group, and I'm going to give it a number. I'm just going to go ahead and choose 0. Now, this virtual port group is going to need an IP address. I'm going to go ahead and give it an IP address of 192.168.1.1 with a /24 mask. I'm going to say no shut, and I'm going to say end. And what I'm going to do is I'm going to say show IP interface brief. And what we'll see now is I do indeed have that virtual port group interface that has been configured. Now, like I said, this interface pokes a hole into the Iox environment that's going to provide the capability of being able to get data in and out. That's its sole purpose. It's also going to need to be noted that this interface must be the gateway of last resort that I'm going to assign to the Docker container, I'm going to assign to the Lxc container when I instantiate it. So that will be the gateway of last resort. It's also going to be important to note that I'm going to have to place an IP address on the guest interface that is going to be in the same subnet as this gateway of last resort. So again, what we need to do is we need to talk about what goes into creating this container. And the good news is this process is not difficult. Now, first, what I want to do is I want to verify that there is no containers currently running on this device. And I'm going to do that by typing show app hosting list. And what we're going to see is there are no applications found. In the context or from the perspective of Lxc, we refer to these Lxc containers as applications. And when we create them, we need to give them a designated app ID. What I'm going to do next is I'm going to say config t, and I'm going to create a Lxc container. I do that by typing app-hosting. I'm going to specify an app ID, which will be the name of this resource, and I'm going to use the well-known guest shell that I mentioned before, because guest shell is going to end up being that CentOS operating system that I was describing earlier. Now, once that's done, I need to provide some additional information. So as an example, I need to tell the Iox service environment that this particular Lxc container is going to be mapped to that virtual port group that I just created. And I do that by logically binding the guest interface to the virtual port group. And I represent it as a gateway. I do that by typing app-vnic, and then I'm going to say use a gateway, and I can use a series of gateways. I'm just going to call this one gateway 1. In fact, if I do a tab or a context sensitive help here, I can have up to 4 gateways. I'm just going to call this one gateway 1. And what I'm going to do is I'm actually going to marry the virtual group, port group 0, to the guest 0 interface, which is this interface right here that's running on my container, or will be running when I instantiate it. Now what I need to do is I need to assign an IP address to that interface. I'm in the gateway config, so all I'm going to do now is I'm going to say guest-IP address, and I'm going to assign an IP address 192.168.1.2, and I'm going to assign it a netmask of 255.255.255.0. All I've done is given it an IP address in the same subnet as the virtual port group, and it is obviously going to have the same mask. Let's go ahead and enter on this. Now, the next thing that I need to do is I need to configure the gateway of last resort. I need to notify the CentOS machine of the IP address that I want it to use as its gateway of last resort to exit the network infrastructure. So what I'm going to do is I'm going to go up one level higher, and I'm going to say app default gateway, and I'm going to specify 192.168.1.1, and I'm going to tell it to send it out of the guest interface 0 that I defined on the device before. It's also important to note, again, I want to provide some level of network service that this resource is going to use. The most basic network service I could offer would be something like DNS. So I would specify that here, and I would do that by typing the name dash server, and I can give it multiples again. I'm just going to say, make this one name server 0, and I'm going to point it to 8.8.8. This process allows me to configure all of the necessary networking resources to allow this device to do its job. Now, what I'm going to do is I'm going to go ahead and I'm going to exit down, and I'm going to repeat my show app hosting list, and let's see if we see anything here. And what we see is that this resource has not instantiated. Now, that's not a surprise, because we really want to have the ability to be able to turn this thing off, turn this thing on, destroy it if we need to. And again, that's going to be incumbent upon us as the admins to tell the system to turn it on, to instantiate it. We do that by typing guestshell, the name of the app that we want to do, and I'm going to say enable. And what we're going to do is when I press enter, this is going to spin this resource up, what we call in the software-defined space instantiation. Once this resource becomes available, I want to validate that I can connect to it. We can see now that in this specific instance, it looks like the Iox Service guest shell application has become operational. What I'm going to do now is I'm going to say show app hosting list, and we should see that we do indeed have the guest shell instance running. Now, a lot of stuff has happened behind the scenes. We created a runtime environment to support Lxc containers. We created an Lxc container. In fact, we created an Lxc container that is already going to have native functionality built into it, like Python. And we can now use this container to do a number of things for us. As an example, I could write an embedded event manager script that could send a command to this Lxc container, have it do things for me that would be easier done in Python than, say, something like tool command language. There are a great number of things that we can implement, and it's also important to understand that this device is also going to have all of that configuration that I applied to it, the gateway of last resort and those things. So I could actually connect to this resource. So I could say guest shell run, and then I could tell it to run the bash shell, which is going to put me into the operating system of this device. So if I say IP, say sudo ipaddr, and we take a look at the output here, I can see that it does indeed have that IP address. Let's see if I can ping my gateway of last resort. So I'm going to say ping 192.168.1.1. Let's see if I can reach it, and I have reachability to it. Let's go ahead and exit out of this device, and it's going to put me right back on the CSR. Well, another thing that I could do is I could say show app-hosting, and I'm going to say detail for app ID guest shell. And let's take a look and see what's going on with this. So again, from the perspective of the iOS XE operating system, we can see that I have an app ID called guest shell. The owner is the Iox runtime environment. We have an operational state of running. We can see in this particular scenario that if I continue to take a look at what's going on, I see how much memory is being used. I can see the interfaces that are working, to include the guest interface that I configured and the virtual port group that it's mapped to. And I can even go down and take a look at more interesting information that if it is actually applied, because I could do things like port forwarding, mapping, and things along those lines. This is going to represent a fully operational system. And this fully operational system is now accessible from the CLI of iOS XE. As an example, if you saw me, I ran the bash shell. What if I did this? What if I said guest shell run Python 3 and hit enter? This is going to put me directly into Python running the version of 3.6.8, and now I could actually write scripts and do configurations. So I wanted to take this as an opportunity to try to illustrate to everyone that the idea of implementing on-box Python has a lot of moving parts, but not a single one of them is overly complex when you take into account the narrative. First, what we're going to do is we're going to make certain that we enable the Lxc Container runtime environment, known as Iox Service. The second thing that we want to do is we want to create that interface virtual port group that we're going to use to provide connectivity and act as the middleman between the Iox runtime environment and the Ios Xe environment. And then once that's done, we create all of the criteria and specifics for instantiating that Lxc container. And once that's done, we're pretty much off to the races just as soon as we enable that process. Now, obviously, this doesn't end here. We've talked about the how. We've talked about the what behind it. But we haven't really discussed the idea of when would this be something that I would want to do and in what circumstances where I would want to implement it. If you would like to see more information about how to leverage the capabilities of these Lxc containers, don't hesitate to ask in the comments below in the video. Also, it would be greatly appreciated if I could get everyone to take the opportunity to like this video if it's helped you in any way. The more likes I get, the further I can extend my reach in YouTube, and also it kind of helps me out with regard to knowing that I'm on the right track, providing the information that everyone needs to know in order to be able to navigate the CCIE Enterprise Infrastructure exam. So until the next video, everybody take care, keep studying, and stay safe.